going to talk about factoring special products, lesson 8.5. If you recall, back in chapter 7, when we were first learning how to factor, or FOIL, we foiled special products. And so now what we're going to do is we're going to undo that foiling with special products. So the first one we're going to take a look at is perfect square trinomials. So if you take a look at your worksheets, we have our perfect square trinomials, and they fit two patterns, a plus b squared and a minus b squared. Okay, when we foiled those, it fit the pattern of a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So all we're going to do is we're going to take trinomials, and we're just going to see if they fit that special pattern. So let's go through the first example. Step 1, find ab and then 2ab. Okay, so let's just look at a. My first term is 4x squared, so let's take the square roots of that. The square root of 4 is 2. The square root of x squared is x. The first term is a perfect square. Okay, my b term actually comes from my last term of my trinomial. So b is going to be the square root of 25. The square root of 25 is 5. So the last term is a perfect square. Our last step now is going to look at our middle term. Does it fit the pattern of 2 times a times b? Now remember, our a and our b are what we just solved for up above. So 2ab is going to be 2 times 2x, that's our a, times 5, that's our b. 2 times 2 is 4, times 5 is 20, and don't forget about our x there. So 2ab is 20x. So the middle term, 20x, is that equal to 2ab? Go back to my original problem, 20x. Sure enough, those are equal. Okay, so therefore, 4x squared plus 20x plus 25 is a perfect square trinomial. Okay. Now, the last thing to get your actual answer will be to substitute the expression back in. So my a value was 2x, my b value was 5. It fits the pattern from up above, a plus b squared. Box your answer. Okay. Next one. Determine whether 9x squared plus 25x plus 36 is a perfect square trinomial. Okay, so first, again, find ab and then 2ab. So, my a value is my 9x squared that we have to take the square root of. The square root of 9 is 3. The square root of x squared, everyone, is x. The first term is a perfect square. Find my b value. It's the last term, 36. Square root of 36 is 6. Okay, let's check my middle term. 2 times 3 is 6, times 6 is 36. Don't forget about x. The middle term for my original problem was 25x, which is not equal to 2ab because we got 36x. So this says stop. Because 25x does not equal 2 times a times b, 9x squared minus 25x plus 36 is not a perfect square trinomial. Okay, that's all there is to it, just fitting the pattern, checking a, b, and the 2ab middle term. Okay, so let's go down and do one of these problems together. Okay, so let's first find our a value. Remember, a is my first term, 9x squared, except I take the square root of that. Square root of 9x squared. Square root of 9 is 3. The square root of x squared, x. Okay? b comes from my last term, 100. But remember, we have to take the square root. Square root of 100 is 10. Okay? Let's find my 2ab. So 2 times a, not 9x squared, but 3x that we found, times times 3 is 6, times 10 is 60, x. Okay, let's go back and check. Is 60x equal to my middle term up above? No. So factor or explain? No, it's not a perfect square trinomial. Okay, 30x, which it gave as our middle term, is not equal to what we found to be 2a times b. Okay, so you guys have these other problems to do. You need to come in to class, get these two checked by myself or Mr. Flynn. Okay, the second lesson for 8.5, the second half of 8.5, is the difference of perfect squares. So this is the other pattern that we fit from chapter 7 when we were foiling. A squared minus b squared can be factored into a plus b times a minus b. Okay, this one doesn't take as many steps as the last pattern. So let's take a look at our first example. 64x squared minus 25. Determine whether it's a difference of perfect squares, and if so, we're going to factor it. So, the first thing we actually look at is the sign that's given to us. So right here, the minus sign indicates it is a difference. We have to start there. So next we're going to find a and b. And it's the same steps from the first half of 8.5. The square root of 64 is 8. The square root of x squared is x. So the first term is a perfect square. Let's check the last term. Square root of 25 is 5. The last term is a perfect square. Easy as that. 64x squared minus 25 is a difference of perfect squares. Okay, so easy as that. Then the last step, though, of course, is to write your answer. Remember, we have to be in the form of plus and minus, so 8x plus 5, 8x minus 5. Box your answer. And remember, for the perfect, or the difference of perfect squares, remember our opposite signs. Okay, next example. Determine whether 4x squared plus 25 is a difference of perfect squares. Okay, right away, determine if it's a difference. Well, what do we have? The plus sign indicates a sum. We don't even have a difference here. So it says stop. The binomial is not a difference, so cannot be a difference of perfect squares. It does not have a greatest common factor either. We probably should have checked that first. So 4x squared plus 25 cannot be factored. It's unfactorable. We're done. Okay. Let's go to our first example. First problem down here. Okay. First one, 25x squared minus 81. Is it a difference? Yes, that minus sign right there says yes. Makes it a difference, not a sum. My a, the square root of 25x squared. Square root of 25 is 5. Square root of x squared, x. B is the square root of 81, which is 9. And since it is a difference and they're perfect squares, like up above, I can write it into my expression. And remember, for the difference of perfect squares, I need a plus and a minus. And now I can go grab my a values of 5x, my b values of 9. Easy enough. Okay? Tomorrow you guys need to get 7 and 8 checked when you come to class. Okay, 8.6, choosing a factoring method. We have all the different factoring tools in our tool belt now, so now it's just a matter of going through and deciding which one is the best one without being told which one to use. So here's a table that they give you, and it's kind of just nice to go through the checklist, and it's going to become second nature for you guys as you become more familiar with polynomials. So the first thing always, so important, check for a greatest common factor. If you don't, it can kind of become a factoring nightmare. So after all the common factors have been taken out, we're going to check a couple things. If it's a binomial, two terms, let's check if it fits our special pattern, okay? If it doesn't fit our special pattern and there's no more greatest common factors to take out, we're done. Can't be factored any further. If it's a trinomial, we have a few more things to check for. Okay, we can check the perfect square trinomial pattern, a plus b squared or a minus b squared. Check those first. Then, if not, I don't really go by the book on that. We kind of go with finding factors, whether it's a sum or a difference, depending on the signs, and whether that middle term is an odd number or not. That tells us a lot about the factors, remember, so don't forget all of our little tricks. If there are 4 or more terms, you have to try by grouping. That's our only thing to try at this point with 4 or more terms, and I don't think that this book is going to be mean about it, so go ahead and try factoring by grouping. So let's go through a couple of examples. So to begin with, we only have to go through how we would factor. You don't have to actually factor it, but I'm going to go ahead and do that just so that we don't get in the habit of not factoring, and plus it's just good practice. So here's our first one, x squared minus x minus 30. Is there a greatest common factor? Well, no, except 1, and we don't count 1 as a greatest common factor. So no greatest common factor to pull out. Okay, is it a trinomial? Yes, 3 terms. Great. If it's a trinomial, let's first check our special patterns. Does it fit a plus b squared or a minus b squared? You actually have to go through the steps and check. My first term is x squared. It's a perfect square. My last term is 30. 30 is not a perfect square, so it doesn't fit the perfect square pattern. We can say no, because the square root of 30 equals 5 point. I don't really care what, something. Okay? So now is a equal to 1 or not? And that is kind of nice to check. Yes, a equals 1. That's my understood coefficient out there in front of x squared that we don't write. So with that being said, I only have to check factors of 30 to see whether I have a difference of -1. So my method down below says factor by checking factors of c that sum to combine to b. Now, of course, I would not say sum here. I would say that have a difference of b. Okay, well, let's go ahead and do that. So because I don't have to check 1, I only have to think about factors of 30. Well, 1 and 30, that difference is going to give me 29. You guys can see where I'm going here. 2 and 15, that's going to be a difference of 13, so on and so forth. Are there 2 factors of 30 that are right next to each other? Yes, 5 and 6 would give me a difference of 1. So I know I can factor it then into x plus 5x minus 6 because of the -1. But we'll stop right there on that one, so we're going to do more of that on the back. So let's go on to the method for the next one. Method for factoring 2x squared minus 50 and then state the method. So we just have to go through our checklist. Does it have a greatest common factor? Just look at your coefficients, 2 and 50. They're both even. Remember, anytime you have even numbers, you have at least a common factor of 2. And so, in this case, with 2 being the coefficient, yes, it has the greatest common factor of 2. Let's go ahead and factor that out right away so I can see what I'm left with. So 2 out of 2x squared, my 2's would cancel, leave me with x squared, minus 50 divided by 2 is 25. Okay, so now this is easier for me to check the other things that need to be checked. Is it a trinomial? No. It's a binomial, right? 2 terms. this factor out in front isn't considered a term because it distributes back through and comes back to my original binomial. Is it a perfect square pattern? Well, in my binomial, my only perfect square pattern is when you do a plus b times a minus b. Remember, you get a squared minus b squared. Your middle terms cancel, and you only have your a and your b term left. Well, I have a perfect square. X squared is a perfect square. Minus, that's good. 25, that's also a perfect square. It fits my pattern of a plus b times a minus b, so perfect square pattern? Yes. So my method would be to factor out my greatest common factor, and then use a plus b times a minus b, which we already have figured out. Okay. So let's put this all together and go on to the back side of your worksheet. We'll get to those other examples in a minute. Okay, so let's go through these factoring steps and actually factor one of these. So we're probably going to have to use more than one factoring method because that's just what algebra does. It gets bigger and better. So, first example, factor 5x squared minus 5x minus 60 completely. Okay, first check if there's a greatest common factor. Well, 5 and 5 definitely have a common factor. Does 5 also go into 60? Yes, it ends in a 0. Don't forget our rules. So let's take out our greatest common factor of 5, which is going to leave me with x squared minus x minus 12. Okay, now let's choose a factoring method. Well, x squared minus x minus 12 is a trinomial. It is a perfect square or not a perfect square? Well, that 12 right there is not a perfect square. So this is not a perfect square. So now we need to find factors of c that will sum, and again I would turn this into difference to b. Okay? So factors of 12 that have a difference of b, which our difference is negative 1. So I'm looking for a difference of negative 1. Now hold the show. Negative 1 or 1 as a coefficient is odd. So when I'm looking at factors of 12, I know I'm going to have at least one odd factor. So that would be 1 and 12, but that gives me a difference of 11. 2 and 6, those are two even factors. Throw those out right away. 3 and 4, 3 and 4. That gives me a difference of 1, right? So now I just have to assign my signs correctly. I want a difference of negative 1. So that means my big factor of 4 goes with the minus sign. My little factor of 3 goes with the plus. So now I'm going to write the complete factorization. Remember back here at the top when I took out that greatest common factor, it has to stay with my factorization. And I'm just going to add in my 3 and my 4 that I found up above. Piece of cake. Go through the check. They FOILed, combined middle terms, plugged in their 5, greatest common factor last step, to get the same trinomial is what we started with. Okay, next example. Excuse me. Factor 16x squared minus 36 completely. Greatest common factor? Well, they're both even, so I know there's at least 2, but I can even go bigger than that. I know they have greatest common factor of 4. Okay, that leaves me with 4x squared minus 9. Alright, 4x squared minus 9 is a trinomial or binomial? Binomial, 2 terms. Is it a difference of perfect squares? Well, and this is where you have to go through all the steps that we learned in 8.5. There is a minus sign, so that's a good start. Is 4x squared a perfect square? I don't know. 4x squared, square root 2x, yes. What about 9? Square root of 9? 3. So it's a perfect square. Difference of perfect square. I'm not going to write that out right there because we just found my perfect squares. So I'm going to use my pattern of a plus b times a minus b. Well, now I get down to this factoring because I already did it up here to check whether it fit my pattern. I'm already done. A is the square root of 4x squared, which we found to be 2x. B is the square root of 9, which we found to be 3. Plug it into my pattern. 2x plus 3 2x minus 3. Notice we can't make this into some kind of a squared term because my signs are different. Okay? Complete factorization. That greatest common factor from up above. We always remember I have to put that into our final answer. So again, 4 times 2x plus 3 times 2x minus 3. They go through the check. Okay? You don't have to be as particular about your checking with the foiling because since it fits that pattern, I know those middle terms should cancel out, 1 plus, 1 minus, to be left with this. Distribute my 4 term back in there, and I'm left with the same answer. Okay, you guys have a lot of practice problems to go through on these. I'm going to